Hello, let's get started. So yeah, actually the light is quite good. I haven't switched on my lamp and it's still kind of looking okay. So yeah, it's ledger of data. So it's Monday, and we are going to talk about the boosting algorithm. So yeah, so today is more like a kind of like chatting episode rather than like coding, because if I want to demonstrate those algorithm, actually it would take quite a while to train whatever data that I'm presenting, and yeah, I just don't feel like doing that. So I gotta just like maybe go through like the discussion about different algorithms, give you an introduction about them, so you kind of have an idea what to choose when you are actually doing some kind of work project yourself. Okay, so first of all, I would like to go over like gradient boosting again. So gradient boosting is kind of something that we have talked about before when we talk about the decision trees. So actually, gradient boost can be used not just for classification but also for regression. But basically, like the way that is kind of trying to achieve the prediction is kind of the same, you know, and is based on a decision tree, but instead of just like one decision tree that we have looked at like maybe 2 or 3 episodes before, that actually is an ensemble of trees. So it's a combination of them. And the difference between the gradient boosting and random forest is that gradient boosting will try to find to build a better tree each time around. So it's kind of building the tree on the go, rather than random forest is like doing some random sampling, just like building different small trees and then combine them together to get a result. But gradient boosting is not. Um, so that's derived from that. Actually, there are different boosting algorithms that use different methods to combine these trees, and also like the most important thing is like how it gonna boost the result, right? How it's gonna improve the result by tweaking the weight of which tree to build, or which tree will give it more of importance to it, so it kind of like have a heavier weight. So when you combine them, then that tree is gonna be you know a more significant tree. So like all these things actually are making a difference. Uh, here comparing different algorithms. So for gradient boosting, if you want to use it, the best place to find it is on scikit-learn, and I think I've came across this before, that you have a gradient boosting classifier. They also have a gradient boosting regressor as well. So if your problem is a regression problem, which you're trying to predict one single value instead of classifier, basically it would be a categorical prediction. So it will predict um, if you have some new data with the feature coming in, then it's predicting which class it belongs to. So that's a classifier. So if you want to predict something that is a certain value, then you want to use a regressor. So for scikit-learn, it's kind of like a standard scikit-learn API that you see that when you started it, there are some parameters that you want to put in. So these parameters basically is kind of the high level parameters that's governing your model. For example, the learning rate. So this is actually determine how fast your algorithm is learning. Basically, it's just like mean that when it got the gradient boosting, how big of a step it's kind of moving towards what believed to be better. Um, so if you have taken a bigger step, which is like making the race faster, of course the training could be faster. But the problem is that if it's close to the end of it, if your step is too fast, then you may actually step over the optimal value. So that's not good. And so yeah, so that's why having like it's not always the bigger the better. Sometimes you have to do some fine tuning of it, and the estimator is actually the number of boosting stages. So yeah, again, like you have to choose like what number actually like performed better. So it's kind of like yeah, so large number actually like better performance, but not always the case. And so there are lots of them. So the default actually is kind of try to be the general purpose one, but of course there's always room to change a little bit. For example, maximum depth. This is how big every tree is. So usually 3 is fine, but sometimes you want to make it slightly smaller. Um, so yeah. So also you can yeah, put in a random state, which is like a number that you put in as a seed for the randomization. So if you have a seed there that is the same, so the next time you run it, the result, even though it randomizes it, but the result would be guaranteed the same. So it's useful if you want to run a trainer model multiple times. If you want to compare the result, then you may want to keep a the same seed, so it's easier for you to control, to kind of eliminate the random factors of it. Okay. Um, Yep. So there is like all this stuff, like also ver verbose is usually like whether you want the what during training there's like some results to be printed out. So you could switch it on or you can just like switch it off. So yeah, those are the ones that usually I care about. And like I said, because it's like a scikit-learn kind of algorithm, that using it is basically more or less the same. You just like fit it with the dot fit here, and oh, I realized that I'm getting darker because like the sun is kind of being covered by a cloud, so I gotta switch on a little bit, and yeah, so I have a little bit of light. Okay, so yeah, so you just use fit to fit it, and then you use a predict to do the prediction. So also you can have a score if you want to, but I think like if you want to measure the last time we talked about different metrics you could use to compare models, so maybe you want to do it some like using other metrics that you pick for this comparison. Um, so yeah, this is quite kind of straightforward, I would say, to use it. Also, like if you use a classifier, usually the predict come with the predict probability that yeah, could let you do some measurement. For example, like last time we talked about the doing the raw curve, then you would need to use this predict proper to measure your model. So yeah, and right, okay, so let's move on. I'm just like looking at apply. This is I've never used it, and also decision. I think these yeah, I already used them, but like that's very interesting. Oh yeah, decision function. Yeah, I think we talked about that last time. Yes. So right, okay, let's move on. Um, to our next boosting. So this is called AdaBoost, which is like very interesting. It's like I at the beginning I was like, oh, that's a girl's name. Is it like kind of a tribute to Ada Lovelace, which is a very famous kind of female like historical figure that kind of really improved the development of computer and AI in the old days. I forgot when, but like yeah, she's definitely like a figure maybe like Victorian time. I'm not sure. Um, yeah, but that's very abnormal during that time. That usually it's already rare for women to be educated, but like she is used in kind of representing the female in tech kind of figure. Um, so yeah, but here, unfortunately, Ada is not means that is actually a tribute to Ada Lovelace. It's actually using the first three characters of the word adaptive because it is adaptive boosting. So basically, Ada boost just means that we would actually give weight to different decision trees to favor the weaker ones during the next step. So this is a very popular picture. I don't know whether that's big enough, but at least you can see the blue and the purple here. So for the first blocks, the box here, that actually like blue one is trying to pick out all the blue crosses. And yeah, so it's kind of like drawing a line there. It's quite bad because like there are a few like blue that is outside of it, and then that okay, I trained it again with another split another decision tree. Then at the box 2, you can see that it kind of draw lines on the right hand side there to separate out those two red minuses. So okay, it's very bad, right? Because in the middle, kind of like there's a mix of both. And so the third time when we need to draw decisions, then consider like what we have done before, right? So we have the middle section, which is always bad. So that's really like something that we have to work on. So when we make the third decision, actually it will kind of favor that, and we try to if you see that those in the middle here, that those three crosses and like those three minuses in the middle, those will be the one that is considered the most important um, factor to need to be separate out. So they are the most important data points in this case. So that's why the decision on the third box is actually a horizontal line there to separate those six data points there. And then, because we have those three boxes, if we combine them, we have the box 4, which is the final result, which can separate those dots, right? So this is a very simple example, so it's easy to illustrate what adaptive boosting is doing. So Scikit-learn also have this algorithm available. So yeah, it should be fairly familiar. You still got this learning range and an estimator, but you have this base estimator. So so the base estimator is actually the weak the decision tree that is we have. So in the box case, actually the base estimator will be this ones, like this to start with, right? Like these two decisions that is quite bad, but they are the base. They are the initial ones to be start with. So you can actually put in some decisions yourself, and but otherwise it would just like use the decision tree, the very simple decision tree classifiers in Scikit-learn, using just like one. So you can see it's just one cut, so maximum depth is one. So instead of like having those like kind of shape that you draw, you only have one cut, one split there. So yeah, it will be used as the base, and it most of the case that's what you want. But yeah, again, like it's just the extra parameters that you could customize. um so yeah, algorithms, there's like semi and semi-R. I won't go into detail here, but you can read it yourself about like what's the difference if you're using AdaBoost. But to be honest, like I rarely use AdaBoost before. Usually I would use more popular algorithms like XGBoost that we got to talk about later. And so yeah, so don't worry too much about AdaBoost. I guess. Um, Right. So random state again, you because like there's some random process involved in building the decision trees. So not building, but like during the ensemble process, there's some like randomization of like sampling. So um, always provide a way for you to input a seed, so to make all your different experiments to be consistent. Um, yeah, so those are the parameters that you can put in to customize your classifier. So again, AdaBoost, there must also be like a regressor for AdaBoost as well. Let me see if I can find it. Nope. Right. Yeah, I do believe there's also AdaBoost regressor here. So yeah, they also provide a regressor just like the gradient boost. The process is similar. It's just that the output would be a single a value rather than a class. Um, so yeah, and also n classes, of course, like how many classes data has and all this stuff will be attributes that you could actually look at. To use it again, it's very similar to gradient boosting, just dot fetch, dot predict, and you can use dot score as well if you want. Also get this predict probability. So basically the same. The only difference is what's inside. And also, I forgot to mention, but I think I covered it last time when I talk about gradient boosting, that you have the staged decision function, all these like different stage that when you are building your boosting, then every stage it will be a new tree. So you can see how it got improved over time when you train it, or it doesn't improve over time when you train it. Then maybe it's a time to stop, or maybe something's wrong. Okay, so that's AdaBoost, very similar to gradient boosting. The only difference is that it would weighted different decisions to try to favor the weak ones. So the next step we would try to enforce them. Right, so XGBoost is super popular, especially in cargo community, because it's kind of provide the possibility to do like parallel training. So like to do something like cargo or competition, you given a time frame, you have to give the best prediction as possible. And yeah, so for those who don't know cargo, actually, cargo, I always suggest you to go there and sign up for a account. Not just because I encourage you to participate in competitions, you can if you want to, but also you have access to a lot of materials there, like for example some data set that are openly available, and also you can sometimes get some other people's suggestion on how to train a model and things like that. So cargo is quite good for that. I've never participated in any competition, or like, well, I've never seriously participated in any competitions. I've just like usually I just use it for the data set. Um, but yeah, cargo competition is quite popular, and it came to a point that because so many people are participating in it, so at the end of the competition, it will be like maybe the winners just like differ by slightly little like accuracy, whatever metrics that they're measuring at. So you're having a way to train your model really, really fast to do different experiment on how to fine tune your model become very important, because it's not just the method. Of course, the method you used, which algorithm, or like how you build the pipeline, all this stuff, and or feature engineering, all of them are important. But because now like the information is so available, and also there are so many people doing it, so yeah, maybe like people will have a similar approach. So the only difference would be how you fine tune your model. So that's why a lot of experiments are needed, and to find those like perfect, the optimal parameters. So yeah, that's why like for things like XGBoost, which it provide a parallelization in training, actually is very favorable. And also because now people are dealing with more and more data, so it's kind of quite popular in the big data kind of space as well, because you can use it with Spark and all this. So these are tools for big data, parallel, training with multiple nodes of computers, cluster of computers. So yeah, so it become popular. And yeah, so that's one of its selling points, parallelization. And also other things like it uses this called Newton boosting, so it's kind of difference from gradient or adaptive boosting is that it remember the calculus, right? So you kind of you differentiate it to find the maximum point. So it's kind of like using those kind of ideas, like calculus ideas, to find a optimal point um, in your training. So yeah, I won't go into detail there. You can grab the link, and check this from Wikipedia actually, so you can find it there. Um, yeah, so yeah, I won't go into like too much mathematical details here, but that's the characteristic of XGBoost and why people like it. And so far it's still like one of the most powerful decision tree and sample algorithm possible. And so actually it got its own, so it's not in scikit-learn, not that I know. So usually you have to install XGBoost as a separate library, and you can see that it's so popular that actually it's like written in other languages as well. But of course you can use it in Python. I do believe that in the back end they optimize it, so it's not purely Python, but that's a good thing. You want it to be fast, right? So yeah, so install it. Um, yeah, you just Python package. So just pip install it. I do believe there's a page saying that, yeah, you pip in storage. And then of course you can use GPU on it with it as well. So that if you wanted to support GPU, you have to like check this page yourself, right? So I will make it bigger. It's easy to see. Yeah. So yeah, so you can check the documentation page for the GPU support. I don't own a GPU, so I can't give you any advice on it. But yeah, that's how you do it. So yeah, and what else? So yeah, you don't want to build from source. It's slightly complicated, like I said, because I do believe they use something in the backend. So yeah, and to use it actually it's not difficult. So you see that like for Python, so this is kind of like a example here that you just put in the parameter in the train. So it's kind of very similar to scikit-learn. You just import it, and then so yeah, this is just like this D matrix thing is just kind of wrapping your training and test data. Um, this is actually a specific file for that, so it's kind of loading that in, and so you just put in your training data there, and put the parameters in train, just train and then predict. It's quite straightforward. So a lot of these algorithms like to use it is quite straightforward because yeah, because like all these complicated kind of training things actually wrap up. So usually you just like train and predict. And yeah, so what else? Like you can so you can distribute it on different places. You can with Dask as well. That's very interesting because Dask I've used it a little bit. So you kind of like a distributed panda thing. So if you have a lot of data that you can't squeeze them all into your internal memory, then Dask is your very good friend to help you out. So yeah. So yeah, it's like yeah. So this main selling point is that it could be distributed. So yeah, it works with whatever that you got Spark all these things that you could do. Right. Okay. So this is XGBoost, very popular one. Um, the next one I want to introduce is Light GBM. So GBM stands for gradient boosting. I don't know machine. So yeah, so it's gradient boosting, but it's well, it put a light in front of it because its selling point is to actually be fast. Um, so I will talk about the difference between XGBoost and LightGBM a little bit later. So LightGBM actually is developed by Microsoft. So yeah, so it's kind of when it came out, people is already like kind of like it because it's developed by a very a big company with lots of resources. Um, so yeah, it's trying to be fast and efficient, and also use lower memory, and so that's why it's called light. And try to be more accurate, but I would say that it really depends on like your data. So which you can't say this is the best for everything. um yeah, it can also do like parallel and GPU like what the XGBoost is doing. And yeah, large scale data, because like when you can do parallel, then it's easier to handle the large data. Okay, so let's have a look. So you can see like from the color scheme that is basically have something to do with Microsoft. Yeah, so let me zoom in again so you can see the word. Um, yeah, I just copy those like things from here. An installation guide, and yeah, I guess is yeah, there's a Python package. I don't know whether you need to install extra things there. So yeah, chances are sometimes you have to like install the external package, which because like usually they are optimized, but maybe not. So you just install like GBM like this, and also it supports GPU, so there are like other installation guides if you're using it with other GPU thing. And yeah, for Mac you have to install this libmp open mp. Yeah, for like all these like more sophisticated algorithms, they would have some external package that is optimizing the algorithm itself. So yeah, you like it. So on top of like the pip install, you usually have to install something else, to kind of like a back end of it. So yeah, so yeah, if you want to use that, you have to have a look. Yeah, for example, you have to really like be able to do the CMake build, things like that. So yeah, you have to like read this to install properly your LightGBM library. Okay. Uh, yeah. So that's that, and then let me have a look at whether they have an example usage there. Quick start. Um, yeah, okay. So can I have some example code here, please? Okay, binary classification. They can do regression as well. So yeah, one thing I don't like is that their documentation is quite scattered. It's quite difficult to see everything. So yeah, so this is just like you configure everything and then I guess you just run it. Yeah, there's no Python code there. Python guy maybe. And yep, sample, 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 sample. Um, Notebooks maybe. This is plotting something. Right. But yeah, we just want to have a look at how to. So you can see that it's very similar to XGBoost. That is has the train, and I guess they will have the predict somewhere as well. So this is just plotting, and right, yeah, this is the metrics. So they didn't run the predict there, um, but yeah, but you can see that this is like very similar because you don't like if you're like you don't want your user to learn something new to be able to use it. You would try to be consistent with all the APIs. So yeah, so it doesn't like make people crazy. Um, so yeah, this is a code example. So you can see that it's very similar to XGBoost. It's almost the same. So you train, and then you can save the model as well. So you can export the model to a file to so it got so it's not just in your memory, so you can load it back in your other Python sections, um, and predict. So it's basically the same as XGBoost, which is very good. Yeah. So okay, so this is just a brief introduction, so I won't go too much into the detail here. And so the difference, okay, so like I showed you, like things are almost the same. So why there are two? So the difference is that inside, when they do the splitting, when building the decision tree, XGBoost actually just do like a pre-sorted splitting. So basically just for all features, you just try to um, you know uh, kind of like build the tree and then like try to decide what is the best, and then um, so it's kind of like it doesn't add anything to it. It's just like all the features, try different split, and then try to think which one is better, and then you just kind of take the best one and then move on from there. Um, but for the light GBM, it uses this gradient-based one-size sampling. So it's actually on top of you just like look at which split actually give you the best result. It also like you know um, so yeah, there are actually details there. Is in the reference article I will show you. But like actually on top of just picking the best one, it will see look at all the different gradient, so how much this one improve the data, and then it would give different weights to them. It's kind of like AdaBoost, but in a different way to uh, give weight to your data. So for the one that actually give the grade the highest gradient, so the one that actually changes the most, the data that could changes the model the most, it would just pick off them, right? And then for the rest, it would just randomly pick some. So it's kind of like giving the weight towards the one that actually could provide a bigger gradient. Um, So by doing this little trick, actually the performance could be a little bit faster, because when you train it, instead of like, if you always pick the same thing, then kind of like you circle around there forever. But now you're just like picking the one that basically would make the, make more drastic changes. So you favor those more. So yeah, you can basically, run around the space and find the optimal point faster. So that's how they're doing it. Um, yeah, like well, I think if you ask the experts, they will have like more to tell. They will have like a bigger debate on it. But I'm just giving an introduction, so I won't go into detail. Again, you can always read some article about this, and actually there are a lot of articles talking about these things. So if you're interested, you can always find something. But that would be taking more than an hour to explain those. Um, right. The next one is cat boost. So cat boots, like the name suggested, cat means category. So not the cat. So I'm so surprised that like all these like algorithm got like really cute names like AdaBoost, cat boots, but actually like it's just taking like the free letter from a word, it just make a difference. So cat boots is actually like designed to use on categorical data. The difference, like from the cat boots from the other boosting algorithm, is that when it is given the categorical data, then you could actually set a parameters called one hot encoding max, something like that, one hot encode max or something like that. We will see when we look at the documentation. Um, so if so you kind of set the limit of how much um, remember that when we talk about the categorical data episode before that, we have for categorical data you need to have one hot encoding, right? Because computer can only deal with numbers. It can't deal with your different categories. So you have to the best, the most uh, accurate way to do it is to do one hot encoding. But the problem is that if you have data that got like loads of different categories, like for example different countries, then well, there's 100 and something like more countries in the world, so you don't want to do one hot encoding on it, because then you will have like loads of features, which is not desirable. So in here, this one hot encoding, you can set a limit to like, let's say 3. I don't know. Let's say 3. So anything under 3, for example, gender, or you can have male, female, others. I don't know. Or maybe let's say you set the limit to be like 7, so you can only have 7 continents. Then it will be one hot encoding. But for countries, it's way above 7, then you will use this formula to label the categorical data. So basically, it's just the count in the class. So for example, you have 2 different classes, like maybe um, I don't know, people who work in farming, or people who doesn't work in farming. I don't know. Um, they have 2 classes, so you count like, okay, in those continents, how many like people from those continents, and actually in no, continent, like countries, because countries is too much, right? So how many people who are in the farming industry who is from these countries, then you count them, and then plus a prior is just a number that is to be set. That's actually like you can think of it as the fine tune constant there, and it's divided by total, how many people are actually from that country, and then plus 1, because we don't want to divide it by 0, because there is a chance that basically there's no data from that, so we don't want it to be divided by 0, so we just plus 1 there. And yeah, that would be the way it's kind of like a count or proportion labeling technique that we can briefly talk about when we talk about categorical data. So it's using kind of that, right? But of course it's a much better version of it. There's actually like some like process to make sure that this counting is like carrying a way that it's not overfitting and all this stuff. But I won't, again, not too much detail. I will show you the article where I found this, and you can read it. Okay, so let's have a look at the documentation and so yeah, also these are so cute. Yeah, like why it is good. Um, so yeah, categorical feature support. I think this is the best selling point of it. And again, like the other boosting, like XGBoost and like GBM is fast and scalable and GPU supported. And well, it's always claimed that the accuracy is good for all these algorithms. In my opinion, they're all like very decent. They are not bad, but depending on your problem, then you may favor one over the others. Fast, of course, you want to be fast. Um, so let's have a look at how you can install it. So how to install. So for Python, yeah, you just pip install it or conda install if you want to. And yep, yeah, so this is quite straightforward. You just do a cat boost. There's also a widget so there's visualization tool that actually you can install as a Jupyter Notebook extension, which is quite good. You can also check that out. And right, so example usage. Yeah, they also provided like an hour package. So yeah, all these stuff yeah, they're not just supporting Python because there's also other communities that's doing data science that I found that useful. Again, a classifier and a regressor. And let's just look at a classifier. Um, so this is more like scikit-learns because it's using fit, not train. But basically they're the same. Fit and predict and oops, yeah. So you can use fit, you can use predict, and whoa. Okay, this is like a lot of detail here. So yeah, you just fit it and then you can predict it. Okay, and yeah, they also have the predict probability, like all the classifiers that we covered today. And yeah, they also this is very similar to scikit-learn actually. So I don't think there's a problem using it. And yeah, so basically you can see that for all these APIs, there's either like the one very similar to scikit-learn or the one that's like XGBoost and like GBM. They are kind of just slightly different. Right. So and yep. So I think that's it for today. So today the episode is slightly shorter, but I think it's good on a Monday, not to be too heavy. Just give you an insight of what to do, like if you want to use boosting algorithms, especially when you have classification problems. I think they are quite good on classification. If your features are categorical, CatBoost is the best choice, I would say. For LightGBM and XGBoost, I think you can do some experiments to compare the two of them. Seems that LightGBM usually is faster, but I'm sure that you will find cases that actually XGBoost needed because they are better. So yeah, this is the article that you can read. That's I found a lot of information from there. This is quite a good comparison and explain a lot of things. Also, they have these like all these example here. You can have a look. So yeah, like the link is here. There's another one that's similar, but this one also explain AdaBoost, so I also included there. Yeah, and that's it for today. That's it from me. So next week, I have no idea yet. So it's your input now to let me know what do you want to know. I may think of something during the week, but as of now, I have no idea. I don't know. Yeah, I'm sure that there will be like lots of things to talk about. But before I jump into something like more specific, like NLP or computer vision and things like that, yeah, I would like to see what you want to cover. So my principle is I will give you an introduction and for details because I'm not like doing a PhD thesis on let's say XGBoost or something like that. I can't give you too much detail, but I can give you an overlook, at least like enough for you to start with. And also I don't want to spend too much time on one single topic. I like giving people ideas rather than have having like to explain one paper or something like that. Because first of all, I can't do it. The second is that I don't like doing it. Um, but regarding that, before the pandemic and stuff, there's always some like a paper reading like groups, a general club, things like that. So yeah, if you want to like study something like really deeper, there's a lot of resources and different opportunity to do that. I would recommend you to do it if you're really interested in those. Um, but so far, I think I have covered the a few uh, very popular boosting algorithm in the market that you may use at some point in your project. Um, Also, I'm thinking what else I could talk about. Yeah, I just have no idea for now. So please let me know. Um, if you can't think of anything now in the chat, of course, I prefer people to chat to me in the chat. But if not now, then you can, uh, send message to me on Twitter. I tend to check it quite often, and my inbox is open. So that's it, and I will see you on Wednesday for Meet Pie. It will still be at 1 UK time, 1 p.m. UK time, but we are actually planning to maybe change it to a later time to accommodate viewers from America. But again, like everything is to be confirmed. So follow me on Twitter. You will see the newest what's going on in my Twitter. Also, I don't know whether I can say it now. Maybe later that we may have another data workshop coming soon. So yeah, things like again, like things like still at the early stage, but more confirmed now. So we may have a data workshop in November. So I can't give you too much detail, but please follow me on Twitter so you know. So a data workshop actually they are built for beginners. Um, so we'll cover possibly like Python basics, Panda basics, and visualization basics. So, but that will be hands-on, and we will have mentors to help you. So that's good because you will have some human interaction there, and also you would hopefully you'll find a buddy, a mentor that could help you. So I suggest like everyone who anyone who is very very new to all this data science stuff joined is also like if you can follow me but like also follow humble data, so it's just at humble data in Twitter. That we would announce any of these workshops that's coming soon. We already have two successful one in the past, so really looking forward to this one. um, and also if you are more experienced in in data science, that we need mentors as well. So actually it's a very satisfying volunteer work that you could actually make friends and be inspired by these new and upcoming data scientists. So yeah, stay tuned, follow me on Twitter, follow Humble Data, and of course, if you haven't done it yet, follow me on Twitch. So next time I go online, you would get a notification. Um, so that's it from me, and stay safe and see you on Wednesday. Bye.